Okay, so we are finding inverses. Now this first page, first and second page really, finding the inverses of all of our 6 trig functions is mainly so that we can fill out this last column over here. Why can I, there we go. This last column is going to be incredibly important to you when you're trying to find inverses. This is going to be almost as important as the unit circle, okay? We need to reference this anytime we're being asked for the inverse of a trig function. Now, before I go on, does anyone know why we would inverse something using trig? What are we trying to find if they're asking you for the inverse of something? The trig inverse of something. Think of it this way. If I am just asking for the sine of a value, if I'm asking for the sine of, I don't know, pi over 2, what does the pi over 2 represent? The, the pi over 2 is the angle, okay? The pi over 2 is telling you the angle. So pi over 2 is 90, right? The sine value at 90 is 1. So this would be 1, right? Instead, if I asked you this, this is the trig value. And what are we trying to find? Oh, I think, Lucy, you were asking me like my end answer. Yeah. Whenever we are inversing, what we're trying to find is actually the angle. So if we just have a straight trig function like this, we're using the angle to find the trig value, the trigonometric value, versus when we're trying to inverse, we're using the value to find the angle of that value, if that makes sense. So just keep this in mind as we're finding these inverses. So the first thing we're going to do is we're going to, I'm going to preface this with every single one of these graphs that we're graphing, we are really, really roughly graphing them. Just really quick so we get an idea of what the inverse looks like, okay? Do not be taking out a ruler and making sure that everything is perfect. We don't have time for that. And we don't need to do that, right? You're not having to graph by hand on these quizzes and tests anymore, right? So we're just really roughly going to sketch it. Okay, so we're looking at our sine function. Looking at this function, what is the immediate issue with just boom finding the inverse of this? No, no cartography today, no. What is the issue? If I were to immediately draw the full inverse of this full function, what would be wrong or what would be the issue with the inverse? Hmm. Yeah, I mean it's not showing. It's not showing the full sine. It's impossible to show the full sine, right? Because it goes on infinitely. But if I were just to immediately draw, mm, not that there's undefined parts, no. Okay, let's stop for a second. How do you find inverse? When I say inverse to you, what should immediately come up in your brain? Yes, thank you, Arnon. You guys listen to me. Okay, yes. You flip X and Y, right? As soon as you see the word inverse, boom. I hit myself too hard there. You flip X and Y, okay? So if I'm taking all of these points and flipping their X and Y values, I'm literally, whoops. This, the Y and X axis here are not on the same scale. So this isn't going to look perfect like it does when we normally find inverse. So those are actually the points through Y equals X. So if we're trying to find the inverse, what we're doing is we're reflecting over the line Y equals X. Now don't draw this, okay? But over on this third column, what we're trying to do is we're trying to graph the inverse, okay? So don't draw this because I want to show you what's wrong. So here, this point is at pi over 2, 1. We'll say this is at 1. This is at -1. So to switch x and y means that my new point is going to be where? If this point is at pi over 2, 1, where's my new point going to be? My inverse point. Right, 1, which we'll say 1 is just over here, and pi over 2 is over here, or up here. You can write these values on here because these are the values we're going to write. So we'll have this point, and then this point down here is at -1. I'm sorry, negative pi over 2, -1. So the inverse of that would be -1, negative pi over 2. And then it does go through 0, 0. And instead of it going down or below the y equals x line, it's going to first go above it and then below it. And this is the line we reflected over. So if I were to graph the rest of this, I would have that. What is wrong with that? It's not a function. Oh my God. Oh my God. It doesn't pass the vertical line test. It's not a function. It's not a function. So we did this in Algebra 2. We did it just a tad at the beginning of this year. We need to do what is called, do you know what it's called? To the original function? To make the inverse a function, what do we do to the original? Yes, Arnon, yes. We have to restrict the domain. Okay. So, remember how I graphed? First I graphed from this point to this point, right? Between those points is fine. It's when I was going beyond those points that caused the issue, right? So, what that means is I need to only graph. Let me erase some of this so it's not so confusing. I need to only graph between this x value and this x value. When I graph between these two, when I only graph this domain, I'm fine. My inverse is still a function. When it starts changing direction, when it starts decreasing, when it was increasing, that's what causes our issue, okay? That's what creates more than one y value for every x value. So, that being said, they love on Math Excel to ask you about domain and ranges, okay? So this original graph, before we restrict the domain, this original graph has what as its domain? Good, all real numbers. And what does it have as its range? What's the lowest y value? Good. Oh, oops, I shifted. And I actually have those y values. There are points on those y values. So it's bracket -1, comma 1. So that is the domain and range of our original. Now, and I'm just quickly going to sketch it. It then wants us to sketch only the restricted domain. So it wants us to graph from -π/2 to π/2. And we'll call this top 1 and this bottom -1. And we're just really, really roughly going to sketch this. It goes through the center point and it goes down and then up. All right. And then if you want, you can put that line of reflection as a reference. It's kind of nice to look at. So you know that if we're trying to find the inverse, you're actually reflecting over that line. Okay, what is the domain of this function that I've graphed? What have I restricted the domain to? Yes, exactly. Yes. We've restricted the domain to -π/2, comma, π/2. That's the only portion of the sine wave we're looking at. Because if we looked at more than this, we would create an inverse that is not a function, which is not allowed. We need to have an inverse function, right? So we're restricting the domain. And what's my range? Yes, it's still -1 to 1. Now, I am going to erase the two portions that make it not a function. This is now the inverse, right? I switched my x and y values. So this point up here was at π/2, comma 1. So that means that that point now goes to 1 π/2. Where this point was at -π/2 and comma -1. And it goes to -1, comma -π/2. Knowing we're switching x and y values, how or what is a quick and easy way to know the domain of this without even looking at the graph, really? What is the domain of this? Okay, and where'd you guys get that from? Right. Remember that the domain of the inverse is the range of the original. And the range of the inverse is the domain of the original. So as we get lazier with doing more of these, we're just going to draw arrows and we're not going to rewrite these because we're lazy. I'm lazy. I don't know if you're lazy, but I am. Oh, can you explain why the curves go this specific way? Yes. Because, and we could look at each and every single perfect point on this graph, but there aren't any other perfect points between 0, 0 and the max point and 0, 0 and the min point. So what you think about is you think, okay, so if I'm centered on my original graph and I'm going to the left, my point is below the line of reflection, right? So if I'm going to the left, it is below. Reflecting it over that line means that it has to be, if I'm going over 1, it has to be now above my line of reflection. So again, if it's below, 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 it needs to be above, above, above. If over here it's above, 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 it's reflecting and it goes below, below, below. That's how I think about it. Okay, so now on to the most important part. We did all this so that you can conceptualize this, right? Draw a picture of the restricted domain on the unit circle. So remember, what is our restricted domain here? What was our restricted domain? Exactly. So if I am thinking about the unit circle, I'm looking at my unit circle, and I told you point to the angle negative pi over 2. From 0, where are you actually moving to get to negative pi over 2? Right. Remember, when an angle is negative, you're going clockwise on your unit circle. So actually, negative pi over 2 creates this line right here. This angle is negative pi over 2. So that's this point right here, creates that angle. And if I'm then going to pi over 2, that's now counterclockwise, a distance of pi over 2, creating this point on our unit circle. So I am only having the domain, only having the values between negative pi over 2 and pi over 2. These values. Let me tell you why this is important. If I had, for example, let me think. If I had, yes, asked you, for example, what is the inverse sine of square root of 2 over 2? Looking at my unit circle, where on my graph, knowing that sine is always the y values, okay? Looking at my unit circle, what angle has a y value of square root of 2 over 2? Pi over 4. What other, there is another one. What other angle has square root of 2 over 2 as the y value? Yes, but 3 pi over 4 is over here. It is not in our domain. It is an incorrect answer, and we cannot list it. So my only answer here is pi over 4. That's our 45-degree angle. We cannot list, so it gives us this example gives us those two angles. This is our true answer. This is not our answer. So when we're answering these questions, when we're trying to find these angles, we have to be looking at our restricted domain to know what is our true answer. Does that make sense? Okay. I'll be going over that. I probably won't have, well, I'll try to have time to go over more examples like that, but I just wanted to introduce it to you now, just in case we run out of time. Okay, so now we do have to find the rest of our inverses. And we're gonna, because we've already introduced this, we're gonna try to go a little bit quicker now. So, looking at cosine, first thing we're gonna do is we're going to ask what is the domain and range of cosine? All real numbers for domain, wonderful. And range. Again, -1 to 1. I'm kind of, and it's okay because we're just writing notes, but I'm mixing notations based on what it's easier to write. So sorry about that. This top one is set notation, the bottom one is interval. Sorry about mixing, but that's what I'm doing. And then what we're going to do is we're going to look at this graph and we're going to ask ourselves, how should we restrict this domain to make sure that the inverse remains a function? Am I going to do it the same way? Am I only going to take values between -π/2 and π/2? If I inverse that, it becomes like a sideways u. Is a sideways u a function? So I see, and I know every class has been guessing this. It is just common practice to always take the restricted domain closest to 0. So 0 should be included, okay? Taking the restricted domain closest to 0 that has positive values. Right. So instead of doing -π to 0, that would work, okay? However, it is common practice to try to always keep your values positive while also including 0. So the restricted domain we would have here is from 0 to π. And third period kind of had a tough time conceptualizing that, but it's just what is done. Yes, could you take any other, could you go from -2π to -π and have the inverse of that be a function? Yes, but it's just common practice to always have as much of the positive angles as possible while starting at 0. So if you can't start at 0, like this one, right? We couldn't start at 0 and go to π. That wouldn't create an inverse that is a function. We have to go into the negatives a little bit and also have some positives with 0 at our center. So here, let's practice that a little bit. What would our restricted domain be here? We're trying to include 0. So would I have this be my domain? Ooh, did I throw you guys for a loop? You want to include a full period, okay? Yes. It would be from -π/2 to π/2 in this case. What about, now these get tough, but what about here? Zero to π. If I did 0 to π and I inverse this, it would look like that. So yes, you're right. We do have to stop here. We have to stop there because if we continue onward, it doesn't create a function. However, can we go more to the left and have it still remain a function? Right, Anna. Yes. Oh, yes, you got it too, Jessica. we're going to push this line. That's our restricted domain. From negative pi over 2 to pi over 2. Because when we inverse this line and this line are not going to be on top of each other. They do not share x values. What about this one? Can I go from negative pi over 2 to pi over 2 on this one? Yes, now it's from, because I have to split this parabola in half. If I include the entire parabola, it won't be a function anymore, the inverse. So I start at 0 and I go to pi. And lastly, what about this one? I don't know if you guys just answered that. I don't know. Okay, yeah, it is the same. It's from 0 to pi. So once we have these, we're never going to ask you, we're not going to ask you to find these on your own, I do not believe. So as long as you have these notes and have these in front of you, you're fine. Like, it's not like you're going to have to find these on your own. All right, so way back up here, cosine. This is what we're restricting to. So if I'm graphing this very quickly, very, very quickly, because we're short on time here. This point was at 0, 1. This point was at 1, 0. Woo. And this point was at, oh, I'm so sorry. What the heck am I doing? Pi over 2, 0. Pi over 2, 0. And this point was at pi 0. So I'm first going to graph those 3 points normally. So we'll call this 1. We'll call this -1. We'll call this pi. Oh my God. I really did just say pi 0 there. So this is our restricted domain. This is the only portion of this function that we're including. So what is our domain here? Yes. And our range? You guys are quiet today. Are you saying stuff or not saying stuff? Because yesterday, third period, I didn't think anyone was saying anything and I had everyone muted. I don't think you're muted. No one is talking. Okay, good. Good to know. All right, so our range, yes, V, -1 to 1. Whoops. So if I'm trying to graph the inverse now, all I do is take those x values and make them my y values. So all of the values I put on the y-axis now go, I'm sorry, on the x-axis now go on the y-axis, and all the values I put on the x-axis, I'm sorry, oh my God. All the values I put on the y-axis now go to the x-axis. So this is 1, -1. So my inverse, let's see, this top point was at 0, 1, so it's now going to 1, 0. This point was at pi over 2, comma 0, so it goes to 0, pi over 2. And this bottom point was at pi -1, so it goes to -1 pi. This is gonna be rough. I did it, barely. And again, if it's easier to conceptualize these while drawing your line of reflection, do it. All right, and then our domain is our originals range, and our range is our originals domain. So my restricted domain is from 0 to pi. So the only angles I'm going to be including on my inverse function answers are from 0 to pi. Any questions on cosine? Okay. Tangent now. And I'm just going to, instead of pausing to ask about these, I'll just answer. Our domain is harder on tangent because we have asymptotes, right? So it is all x values except for our asymptotes, which our asymptotes are located at pi over 2 plus or minus, now the distance between each asymptote is a distance of pi. So it's pi over 2 plus or minus pi times any integer or n. I believe, I think that you guys realize this by now, but I think that Math Excel says integers not as n's but k's, which is really strange. Like it's accepted across the world that n is like the letter for an integer, and then Math Excel just whoop does k. Oh well, Math Excel is funny. And my range is now all real numbers. So then, if I am trying to only graph my restricted domain, let's see here. We have pi over 2, negative pi over 2. Those are our asymptotes, right? And I have this. So my domain is, now, this is good to note. What is my domain? Right. Yes, Arnon and Anna. Why? Why is it different? Right, because yes, Suma, because of the asymptotes, we cannot actually be those x values, so our domain does not include them. Okay? Then our range, just like before, is all real numbers. So if I'm trying to graph the inverse of this, my asymptotes now, so my asymptotes are x values that your graph cannot be, right? So now the inverse has y values that the graph cannot be. So those vertical asymptotes turn into these horizontal asymptotes. So we have pi over 2. That is our first horizontal asymptote. And we have negative pi over 2. And 0, 0, this is our line of reflection, meaning that I'm trying to draw the inverse. What was above the line will now go below the line, and what was below will now go. So it's going to go like this. Does that make sense? Does my logic make sense of what was below goes above and what was above goes below? I'm sure that's the perfectly mathematical way to think about it, but that's how my brain thinks about it. Okay, so then we also, what? No, that's not what I wanted. So then we also know that our new domain is our old range. So it's x is an element of all real numbers where our new range was or is our old domain. So parenthesis, negative pi over 2, comma, pi over 2. Because we're not including negative pi over 2 and pi over 2 in our restricted domain, what that means for us is that at negative pi over 2, it's not included, open dot. And at pi over 2, not included, open dot. Undefined. So if your problem asks you for the inverse tan of pi over 2, your answer would be undefined. Any questions here? Okay. So I think we're running low on time. So what do I want to do and what do I not want to do? We already found the restricted domains, right? So here, just really quickly, our restricted domain is from negative pi over 2. It's included, comma. There is an asymptote. There is an asymptote in the middle of that domain. So we have to put 0 union with 0 pi over 2. And our range is same exact concept. We have a missing section in the middle there. So it starts at negative infinity, goes up to negative 1. It actually is negative 1, so we put a bracket, union with 1 to infinity. I'm not really going to bother to graph this right now. And the domain of my inverse is the range, and the range of my inverse is the domain. So the only values I'm including are from negative pi over 2 to pi over 2, and it cannot be 0. On the next one, I'm going to do the same thing just real quick. We have, again, an asymptote in the middle of our restricted domain, so we are starting at 0. And we are actually equal to 0. 2, our asymptote is at pi over 2 this time. Can't touch it, so it's parenthesis, union with parenthesis pi over 2, comma, we're stopping at pi. It is equal to pi, so we put a bracket. Our range is, again, the same thing as it was for cosecant, negative infinity to negative 1, bracket, union with bracket 1, comma, infinity. They did not give us enough room down there. And again, our domain is the originals range, and our range is the middle originals domain. So I'm going from this time 0 to pi. Open dot pi over 2. And last but not least, cotangent. Here, oh, this one's back to the easy ones because we don't have an asymptote in the middle, right? So our domain, why won't it zoom in? Now we are starting on an asymptote, so it is a parenthesis at 0, and we're ending at another asymptote, so it is another parenthesis. Where our range is all real numbers. I will graph these on the key, so if you're curious as to what they look like, you can see what they look like, but I really want to get more done here. Domain and range. All right. And we go from 0 to pi. Do you notice anything about these on the back? These unit circle accepted angles? Oh, thank you so much. Thank you so much, Anna. Yes, you're right. Let's just do it all over again. They should be open dots because we are starting and ending on an asymptote. Do you notice anything about this last column on the back versus the last column on the front? Nothing? It's okay. So sine and cosecant have the same values except for that middle little issue there at 0. And cosine and secant also have the same values except for, again, that little issue at pi over 2. Tangent and cotangent, however, are different. Cotangent and tangent are different. Any questions on any of these restricted domains?